not in it for the money. I'm here looking for the real thing. Kissing in the moonlight, movies on a late night, getting old, yeah. I've been there.
Algebra 1 students, welcome to your 6.4 notes, applications of linear systems. By the way, that was a personal request from somebody for pentatonics. So hopefully you enjoyed that. I've heard some of their stuff that's pretty good. So anyhow, applications of linear systems. Folks, in this section, you're going to have the ability to choose, make a decision, or pick which method you use to solve your systems of equations. This is a little bit of a cipher right here to show you kind of an example of when you might pick graphing or when you might pick substitution or elimination. So you can pick in this section which method you choose to use. I would recommend that you dabble with a little bit of all of them so you don't get kind of stuck or in a rut or whatever. But anyhow, systems of equations are useful for modeling problems involving several different things such as mixtures, rates, break-even points. And break-even points in business is going to be when the income equals the expenses. So we're going to take a look at some real-world applications on how to solve systems of equations. All right, for number one, we have a bracelet designer sells his product for $5. Each bracelet costs $2.25 to create. The designer also had $1,485 of expenses to start his company. How many bracelets must he sell to break even? All right, so we're going to start off by defining our variables, and we can typically find those if we analyze the last sentence of our word problem. All right, so we're going to be dealing with bracelets, and we're going to be dealing with break even. All right. So I'm not going to use B and E because those are going to get mixed up. Plus E is something you're going to learn about later in math. So I'm going to choose X to be my bracelets. And I'm going to choose Y to be my expenses. All right, when we do that, we need to set up two separate equations for our system of equations. The first equation that I'm going to set up, it's kind of interesting because my expenses and my break-even point, my expenses are kind of synonymous with like how much profit I'm bringing in or how much income I'm bringing in. So this one's kind of an interesting version of what Y is going to be equal to. Y could actually be equal to the expenses or the income in this particular case. So for the first system of equation, I'm going to say Y is equal to 5X. All right, because I'm going to earn $5 for every bracelet that I sell. And then for my second system of equations, or my second equation, I'm going to have my expenses, which are 2.25 per bracelet, so 2.25 times X, plus my initial expense to set up my factory of $1,485. So next I get to choose a method and solve. I can quickly see that I've got something that Y is equal to right there, so I'm going to go ahead and plug that in everywhere I see Y. And I end up with basically setting these two equations equal to each other, which is kind of interesting because that's what we were trying to do to get our break-even point. So there you go, 1,485. Let's see if Mr. Bear can write correctly today. Okay, so I'm going to get all of my variables on the left-hand side this time. So that way I don't have a gigantic negative expense. So I've got minus 2.25x on both sides of my equation here, which means that I've got 2.75x equals 1,485. All right, so basically I'm making about 2.75 margin on each bracelet. You'll learn that sort of terminology later, maybe in a business class, but for now let's figure out how we solve this one. Let's get X by itself by dividing both sides by 2.75. And when we do that, I'm going to pause it and use my calculator. All right, I figured out that x is going to be equal to 540. Basically, x is our bracelets. So we've answered our problem on this particular one. We don't need to figure out how much, expense or income would be. And actually, if we were to do that, we would end up with that it would be 0, because we would actually that would be our break-even point. So this would be 540 would be the amount of bracelets that we would need to sell to break even. And we don't want to miss any points on these, so you do need to write out your sentence where it says we need to sell at least 540 bracelets to break even. In other words, we need to put this into context, okay? So make sure you're doing that on your problems. 2 aquariums are being filled simultaneously. An 800-gallon tank has 100 gallons and is being filled at a rate of 12 gallons per minute. An 1,100-gallon tank has 200 gallons and is being filled at a rate of 7 gallons per minute. After how many minutes will the 2 tanks have the same amount of water? And again, as always, I'm going to analyze that very last sentence to figure out what my variables are going to be, or to define my variables. I'm going to have one variable be minutes, and one variable be the amount of water. So I'm going to choose M and A. And you guessed it, M is going to be my minutes, and A is going to be my amount of H2O. Okay, so I need to write a system of equations that represents this situation that is occurring. All right, and this is basically the slope-intercept form of the equation of a line for both of these. I've got y is equal to 800 gallons. That's going to be like my y-intercept. All right, oops, nope, it's not. My 100 gallons is going to be my starting point, so that's going to be like my y-intercept. That's the part that's like, okay, I'm starting there, and I am increasing at a rate of 12 gallons per minute. All right, so I would say 12 M right there. And instead of having Y right there, I made a mistake. I should have A right there. All right, for my other equation, I'm going to have A right here instead of Y like I did a minute ago. And it's very similar. I've got some extraneous information there. What I do need is that 200 gallons. That's how much water is already in my tank, so I'm going to put that right out there. That's like my y-intercept if I was graphing this. And it's being filled at a rate of 7 gallons per minute. All right, so I'm going to say M right there. And I need a little plus sign right in between those two guys. So these are my systems of equations. And on these, I also need to make a decision on how I'm going to solve this, or what method I'm going to use in order to solve it. And I'm again going to choose the method of substitution. I'm trying to figure out when these 2 tanks are going to have the exact same amount of water in them. And I also happen to know what amount of water they're going to need in them, because I have what A is equal to there and what A is equal to there. So I just need to set these 2 equations equal to each other, basically. So I've got 12M plus 100 is equal to 7M plus 200. And when I solve that for M, that's going to be the amount of minutes, or the amount of time that it takes for them to have the exact same amount of water in them. So I'm going to start by getting all of my variables on the left-hand side, and I'm going to subtract 7M from both sides. That's going to give me 5M on this side, and this side's still going to have 200. Then I'm going to subtract 100 from both sides of my equation, and I'm going to have 5M is equal to 100. And then when I divide both sides by 5, I would see that M is equal to 20 minutes. All right. And I do need to give that some context or use a sentence. So I'm going to pause the video and write my sentence. You should do the same. All right, so my sentence says after 20 minutes, the two tanks will have the same amount of water. On to the next one. All right, Mr. Hale is riding his wave runner on a river. It takes him 30 minutes to travel 16 miles downstream. The trip back, though, takes an hour. His speedometer shows a constant rate of speed for both trips. How fast was the wave runner traveling in relation to the water? And how fast was the river's current moving? All right, note that distance equals rate times time. All right, so folks, when we start these, I always like to analyze that last sentence to figure out how I'm going to define my variables. And I am going to call my wave runner J, and that's because I like to call them jet skis. All right, I call them jet skis. Same thing as a wave runner. I know everybody else likes to call them different things based on what they really are, but every single one of them to me is a jet ski, so there you go. There's something about Mr. Bear that you need to know. And then I'm going to use W for the rate of my water. So I've got the wave runner there, my jet ski, that I'm going to call J, and my water, how fast is the water going, so my water speed. Okay, so now I need to figure out, I need to write my system of equations. So I'm going to go distance, which is 16 miles, and the first trip, I've got help from the river, so I've got J plus W, and I'm going to do that trip and how fast. My rate, J plus W, multiplied by my time, so 30 minutes, I'm going to call that 0.5 hours. And then I'm going to have a similar equation set up. So this one's going to be a little different. Plus I need to make a set of parentheses right there. Don't let me forget that. All right, so this time I've got my jet ski, and I'm going against the water. All right, this is a very similar problem to our airplane problem that we did in class where we were going with the wind or against the wind. And this one we do in an hour, so we multiply that by a 1. All right, so what I want you to do is go ahead and pause your video and figure out what your jet ski's speed will be and what your water speed is. All right, folks, hopefully you paused your video and did your work on your own. I used substitution when I solved these two systems of equations, which means I had to take the first equation and multiply it by 2, which caused my fractions to go away. Then I went ahead and solved for J because my W's canceled out or they eliminated. And I wrote my sentence right up here. I did what you guys do a lot where you do all of your work and then you run out of space. So you got to figure out where else to write stuff and you write your answer above the problem, which makes grading things a little bit fun. All right, on to the next one. All right, everybody, due to the restrictions of YouTube, I know that I'm going to run over on my time limit for this video. So what I want you to do is pause this screen, read the problem on your own, and then I'm going to show you how to do the setup. Okay, hopefully you paused your video. Like I said, due to the restrictions of YouTube, I got to cut this a little short. What I'm going to do is I'm going to show you guys the very last problem on your notes in class. And so for those of you who would like to finish this problem and get number 5 correct, you will get extra credit. I don't hand out a whole lot of that, so some of you might choose to take advantage of that. But this is a business problem, very real application to it. I used A for the amount of money in account A, B for the amount of money in account B. When you add those together, you're going to get $1,200. That's the total amount invested. The interest total equals $117. So the second equation is how I set up the interest. And folks, we will see you in class ready to work.